Today I'm starting with a new video series about Angular Framework, and in this series you will learn all the things you need to master Angular Framework. I'll start with basic stuff like components and pipes and slowly progress the most complex features of this framework. So let's start. In this section I'm gonna explain what Angular is, give some brief overview of its features and explain why you should use it. But before we start, make sure to check my channel for more videos and tutorials about front-end development. Now, let's start. Angular is an opinionated UI framework for building mobile and desktop applications. And it's built using TypeScript by Google. You probably heard about that one. Also, it is an open source and helps us build dynamic and single-page applications. It is completely based on components. It consists of several components which forms a tree structure with parent and child components. Angular's versions beyond 2+ are generally known as Angular only. The very first version of Angular is known as AngularJS. So, why Angular? Well, because it's supported on various platforms, web, mobile, desktop, native. It's powerful, modern, has nice ecosystem, and it's just cool. Not convinced? Let me give you some facts. Angular presents you not only the tools but also design patterns to build your project in a maintainable way. When an Angular application is crafted properly, you don't end up with a tangle of classes and methods that are hard to modify and even harder to test. The code is structured conveniently and you won't need to spend much time in order to understand what is going on. It's JavaScript, but better. Angular is built with TypeScript, which in turn relies on JS ES6. You don't need to learn a totally new language, but you still receive features like static typing, interfaces, classes, namespaces, decorators, etc. No need to reinvent the bicycle. With Angular, you already have lots of tools to start crafting the application right way. You have directives to give HTML elements dynamic behavior. You can power up the forms using form control and introduce various validation rules. You may easily send asynchronous HTTP requests of various types. You can set up routing with little hassle. And there are many more goodies that Angular can offer us. Components are decoupled. Angular strives to remove the tight coupling between various components of the application. Injection happens in Node.js style, and you may replace various components with ease. All DOM manipulation happens where it should happen. With Angular, you don't tightly couple presentation and application logic, making your markup much cleaner and simpler. Testing is at the heart. Angular is meant to be thoroughly tested, and it supports both unit and end-to-end testing. Angular is mobile and desktop ready, meaning you have one framework for multiple platforms. Angular is actively maintained and has a large community and ecosystem. You can find lots of materials on this framework as well as many useful third-party tools. The architecture diagram identifies the 8 main building blocks of an Angular application. Angular apps are modular, and Angular has its own modularity system called Angular modules or NG modules. Every Angular app has at least one Angular module class, the root module, conveniently named app module. While the root module may be the only module in a small application, most apps have many more feature modules, each a cohesive block of code dedicated to an application domain, a workflow, or a closely related set of capabilities. An Angular module, whether a root or a feature, is a class with an ng module decorator. Angular templates are dynamic. When Angular renders them, it transforms the DOM according to the instructions given by directives. Metadata tells Angular how to process a class. Service is a broad category encompassing any value, function, or feature that your application needs. Almost anything can be a service. A service is typically a class with a narrow, well-defined purpose. It should do something specific and do it well. Examples include logging service, data service, message bus, tax calculator, application configuration. There is nothing specifically about Angular services. Angular has no definition of a service. There is no service-based class and no place to register a service. Yet, services are fundamental to any Angular application. Components are big consumers of services. Now, let's talk more about components in detail. Components are the main building block of Angular application. Each component consists of an HTML template that declares what renders on the page, a TypeScript class that defines behavior, a CSS selector that defines how the component is used in a template, and optionally, CSS styles applied to the component. A component must belong to an ng module in order for it to be available to another component. Why do we use components? There are many reasons, but the main ones are we are able to reuse our code so we don't duplicate it, simplify component-based architecture, easy to do error handling, and breaking down the complexity into smaller pieces. Prerequisites for these sections are install the Angular CLI and create an Angular workspace with initial application. If you don't have a project, you can create one using ng-new project name, where project name is the name of your application. Although the Angular CLI is the easiest way to create an Angular component, in this tutorial we will create our component manually. To create a new component, navigate your Angular project directory. Create a new file, hello world component ts file. At the top of the file, add the following import statement. After the import statement, add a component decorator. Decorator marks a class as an Angular component and provides metadata that decides how the component is used at runtime. Choose CSS selector for the component. This is the tag which you will be using in your template files to render your component. Define the HTML template that the component uses to display information. In most cases, this template is a separate HTML file, but I'll use it within this file. To define a template as external file, add a template URL property to the component decorator. For a template within the same file, use template property. Select the styles for the component's template. In most cases, you define the styles for your component's template in a separate file. Again, I will use it within the file. To declare the styles for a component in a separate file, add a style URLs property to the itComponent decorator. But for the styles within the component, add styles property. Add a class statement that includes the code for the component. Here we can define properties, methods, catch component lifecycle events, and do dependency injection, but I'll talk more about these in the next video. Now, all the public properties that you define in the class are accessible in the HTML template, and this is one of the most powerful things here. I'll create a title property, and I will include it in the HTML. Import that new file in the module where you want to use it. To make it available for the whole app, import it in the root module. In order to see our component, we can use our CSS selector inside of our app component or any other component. And this is your first component, very simple though, which you can reuse across your app. In this section, we are talking about lifecycle hooks. They are special functionality in Angular that allows us to hook into and run code at a specific lifecycle event of a component or directive. You can look at them as phases of component life, like every living being has. They get born, they change, they grow, and eventually they die. With lifecycle hooks, we can gain better control of our application. When do we want to use them? For example, if you want to fetch some data and display it in your component, you will do that inside of ng-oninit lifecycle when its component gets initialized. Or if you need to clean up your component, remove some subscriptions you might have to prevent memory leaks, you will do that inside of ng-ondestroy lifecycle hook, just before component gets destroyed. This is the list of all hooks in exact order how they get initialized, but most used ones are oninit, onChanges, and onDestroy. Let's implement the ng-oninit hook, as you will be using this hook the most. First, import oninit interface from Angular core. Next, we want to implement this interface inside of our class. To implement any hook, you just need to add an ng to the interface name and you will get the method needed for implementation. So in this case, it's ng on init. We will create a simple function for logging some values to the console. Now, I will create a property that will save that function so that we can clean it up at the end. In the ng on init method, let's create a simple setInterval method which will make a console log on every second. If you leave our component like this, when the component gets destroyed, our interval method will continue to log to console. To fix this side effect, we need to use the ng onDestroy hook. Import onDestroy interface and place it next to onInit. Now, create the ng onDestroy method, and in this method, you need to clean up this interval. Simply use clearInterval method with our property passed as an argument. And now our component has been cleaned up. Using Lifecycle hooks, we can fine-tune the behavior of our components during creation, update, and destruction. Next, text interpolation. Text interpolation in Angular is a one-way data binding technique that is used to transfer the data from a TypeScript code to an HTML template. It uses the template expression in double curly braces, also known as a mustache syntax, to display the data from the component to the view. When do we need text interpolation? Every time we want to make something dynamic in our HTML template. To illustrate how interpolation works, let's create a new variable in our TS class. You can use interpolation to display the value of this variable in the corresponding component template. Angular replaces title with the string value of the corresponding component property. In this case, the value is hello world. Now, let's talk about template expressions. A template expression produces a value and appears within double curly braces. Let me show you an example. Angular resolves the expression and assigns it to a property of a binding target. Template expressions are similar to JavaScript, except you can't use assignments. Also, operators such as new, typeof, or instanceof. You can't use chaining expressions, decrement or increment operators, and some of the ES 2015 plus operators. Expressions can also invoke methods, so let's create one. Name of our method will be getMin, and in this method we are returning value for displaying it in our template. In this case, it will be a minimum value. Couple of things I want to mention. You should keep application logic in the component as much as possible, where it is easier to develop and test. Also, expressions should finish quickly to keep the user experience as efficient as possible, especially on slower devices. And template expression should not change any application state other than the value of the target property. Reading a component value should not change some other displayed values. Now let's learn how to communicate between the components. An Angular application usually consists of many separated components, and in order to make them work together, we need communication between them. You can think of components as family members, and if communication between the parents and kids is fluent and efficient, your home will be a happy place. There are 4 ways to communicate between the Angular components. Binding using input and output, reference by using viewChild and ContentChild, provider using services, and template outlet. In this tutorial, I'm gonna cover the first 2 ways as we haven't covered services yet, and the template outlet is a little bit advanced. First use case is when we want to send data from parent to child using input decorator. Input decorator takes the value passed from parent and stores that value in the child property. Let me create 2 components using Angular CLI. I will run the following commands: ng generate component parent and ng generate component child. In our child component, I will import input decorator and name our input as child message of type string. In the template of the same component, I will display this property, which is going to be passed from a parent. Now, inside of our parent component in the template, we want to place our child component and to pass the value to the input property we just created. The name of the property is the one we defined in the child component, and the value is going to be a hello message. Next, we want to place our parent component inside of our root component. And if we preview it, we can see their message from parent has been displayed in our child component. Second use case is when we want to send data from child to parent using output decorator. Output decorator marks a property in a child component as a doorway through which data can travel from the child to the parent. This approach is ideal when you want to share data that occurs on things like button click, form entries, and other user events. To raise an event, an output must have the type of event emitter, which is a class in the Angular core that used to emit custom events. In the child component, import output decorator and event emitter. We declare a message event variable with the output decorator and set it to equal to a new event emitter. Then we create a function named sendMessage that calls emit on this event with the message we want to send. Lastly, we create a button to trigger this function. In the parent, I will create a function to receive the message, and I will just simply alert this message for demonstration purposes. Now, in the parent template, call our function once the event from the child component occurs. And the name of that event is the one that we defined with output decorator. Very simple and effective. Compared with all other approaches for communication, binding is the cleanest and the simplest one. It is the most maintainable way for passing data. Hence, binding is always the most preferable way that Angular developers should consider first. Third use case is when we want to send data from child to parent using viewChild. ViewChild allows the child component to be injected into a parent component. It will give the parent access to its properties and functions. A child won't be available to give access until the view has been initialized. This means we need to implement the AfterViewInit Lifecycle hook to receive the data from the child. First, create a message property in our child component. Import ViewChild and AfterViewInit from Angular core and our child component. For our ViewChild decorator, pass our child component as an argument and name it as child. Next, implement AfterViewInit Lifecycle hook. By the way, to learn more about Angular hooks, check the part 2 of this video series. Inside the ngAfterViewInit method, just alert the message property of our child so that you can see that we have access to it. And if we start our application, you can see that we are displaying a message from the child component. Next, we are discussing component styles. Being able to style your app is very important because it allows you to make your app unique and attractive in a way it's like a beauty salon. World without CSS would be an ugly place. CSS gives us the opportunity to play with a page layout, adjust colors and fonts, add effects to images, and so on. How to add styles to Angular components? There are 3 ways you can apply style: by setting style or style URLs metadata, inline the template HTML, and 3 with CSS imports. I created one blank component with only h2 tag in the view to demonstrate all different ways we can style it. You can add a styles array property to the component decorator. Each string in the array defines some CSS for this component. You can load styles from external CSS files by adding a styles URL property to a component's decorator. And now, styles from external file are being applied. Next, you can embed CSS styles directly into the HTML template by putting them inside of style tags. You can also write link tags into the component's HTML template. One note here is to be sure to include the linked styles file among the assets to be copied to the server when building. You can also import CSS files into the CSS files using the standard CSS import rule. I usually use this approach to import the variables. Reminder, these styles apply only to this component. So if you have h1 tag in a child or parent component, it won't be applied there. By default, view encapsulation is set to emulated and emulates the behavior of the shadow DOM by preprocessing and renaming CSS code to effectively scope the CSS to the component's view. We can remove these additional CSS selectors by setting encapsulation to none. And now our styles are being applied globally. Global styles are by default defined in the style CSS file, and you can define more global styles in the Angular JSON file. Another thing is that if you're building with the CLI, you can write style files in Sass, Lass, or Stylus, and specify those files in the component style URLs metadata with the appropriate extension, as in the following example. Now let's talk about special selectors. Use the host pseudo-class selector to target styles in the element that hosts the component, as opposite to target elements inside the component's template. For example, we can write the following code. We can style host styles with the given selector by using the function form as the following. And if you add active class to host component, you can see that styles are being applied. Now, let's talk about host context. Sometimes it's useful to apply styles based on some condition outside of the component's view. For example, a CSS theme class could be applied to the document body element, and you want to change how your component looks based on that. The following example applies a background color style to all H2 elements inside of the component, only if ancestor element has the CSS class ThemeLight. Now, if you go to root element and add ThemeLight class, you can see those styles. And that's it. Now, let's see what is ng content. ng content uses the content projection to take HTML of another component and to display it inside itself. To me, it's similar to a film projector, where you have a slot to insert your content, which is going to be displayed on the screen. It's a very powerful tool when you're building components intended for reuse. I see it used extensively in frameworks such as ng Material. When do you want to use ng content? Anytime you want to inject any kind of HTML into a component, you can do so with ng content. I have two components, child and root component, to demonstrate this feature. Inside the child component, I will create some static content, so I'll add h2 title, and below that title, I want to show the dynamic content. So I will create an ng content tag. With the ng content element in place, users of this component can now project their own message into the component. To do that, let me insert a child inside of our root component. And I will pass a paragraph with a message. As you can see, the ng content element is a placeholder that does not create a real DOM element. Now, except single, a component can have multiple slots. Each slot can specify a CSS selector that determines which content goes into that slot. This pattern is referred to as multi-slot content projection. You can accomplish this task by using the select attribute of ng content. Inside of our child component, add one more ng content tag. We can make our component to be like a question and answer card. So in the first ng content, add question selector, and for the second ng content, add answer selector. Now, we can use these selectors to send different content. In our root component, I will create h3 title with a question selector, and I will type this question text. Below, I will create a paragraph with an answer selector, and I will type an answer text. Also, there are a couple other ways to create multi-slot content projection, but we haven't covered conditionals yet. As you can see, it's really easy to create reusable dynamic components. This approach can be used for much more complex user interfaces, but I showed you this simple example to understand the concept. Next, let's discuss template statements. A template statement is something that responds to an event raised by a target like an element, component, or directive. So it's the same thing as if someone is calling you, which is an event, and you're answering that phone call, which is the response, and in our example, template statement. It commits side effects as it changes the fields in the component. Now, I will show you how to update class properties using a template statement. I have a blank component, and in our template, I will create a Boolean property named showText with a value of false. Below that, I will create a method named toggleText. It's not going to return anything at this point. All we are going to do here is to toggle our showText value on every method call. Usually, we would use this kind of property to toggle the state in the view, but we haven't covered conditionals yet. So, in the template, I'm going to create a button which will respond on a click event, and it will call this toggle method. Below that, I will just display our showText property. And now, when I click the button, you can see that it toggles its value using template statement. And in this example, toggleText is template statement. This statement context may also refer to properties of the template's own context. In the following example, toggleText takes the template's own event object as an argument. If you log that object, you can see that it contains various information about the target and the event that occurred. Passing arguments can be very useful when you're submitting the forms or looping through arrays, and you need to access a specific element. One note here is that the context of a template statement can be the component class instance or the template. Because of this, template statements cannot refer to anything the global namespace, such as window or document. For example, template statement can't call console.log or mathmax. Pipes. Pipes are simply functions you can use in your templates to accept an input value and return a formatted value. In this case, you can see your data as untouched clay, which is ready to be molded. At the beginning, it's not very nice or clear what it's for, but with a little bit of crafting and molding, you can get the end results that you wanted. Angular provides built-in pipes for typical data transformation like date pipe, uppercase pipe, currency pipe, percent pipe, and similar. In my app component, I will define a date property with a value of new date. If we just display our date object in our template, you can see what kind of format we get. It's not very user-friendly. Now, let's make it nicer. To apply a pipe, use the pipe operator within a template expression along with the name of the pipe, which is the date for the built-in date pipe. Now, this is much more readable. One note here, date pipe is executed only when it detects a pure change to the input value. A pure change is either a change to a primitive input value such as string, number, boolean, or symbol, or a changed object reference such as date, array, function, or object. If you still don't like the output format of your date, you can fine-tune it by using optional parameters. There are predefined options like short or long and others. Or you can customize it completely. For example, I'll write 4 E's for a day in a week, 4 M's for a month, 1 lowercase d for a day in a month, and 1 lowercase y for a year. You can also chain multiple pipes as well. You just add another pipe operator and a pipe name. Now, we can create custom pipes as well. Let's create a simple greetings pipe that will concatenate hello to pass name. I'll use Angular CLI to generate this file for me. So type ng generate pipe and the name is greetings pipe. In our pipe, we have boilerplate code generated. You can see that pipe decorator has been imported with a name property, which we can use to call our pipe in our templates. Also, there is a pipe transform interface, which needs to be implemented. This interface requires the transform method to be implemented, and this method receives a value passed from a template. In our case, it will be a string. And the second parameter is for optional params from pipe itself. Return type in our case is going to be a string. Now, all we are going to do here is to concatenate hello on the pass string and return that. Now, in our template, we can call our custom pipe with the greetings pipe name that we defined, and I will pass world as our string. Now, that's how you create a custom pipes. Angular pipes are very simple but useful functionality provided by Angular, and you will use them a lot. Once again, for a detailed list of all pipes, check the documentation link from the description. Now, let's discuss property binding. Property binding moves a value in one direction, so you can see it as one-way street. You can go the other way. Value goes from class property to target element property. Property binding in Angular helps you set values for properties of HTML elements or directives. With property binding, you can do things as toggle button functionality, set paths programmatically, and share values between components. To bind the source property of an image element to a component's property, place the target source in the square brackets followed by an equal sign, and then the property. The property here is item image URL. Declare the item image URL property in the class, in this case app component. A common point of confusion is between the attribute callspan and the property callspan. Notice that these two names differ by only a single letter. If you wrote something like this, you'd get template parse error. Interpolation and property binding can set only properties, not attributes. Instead, you'd use property binding and write it like this. Another example is disabling a button when the component says that it's unchanged. To disable a button's functionality depending on a Boolean value, bind the DOM disable property to a property in the class that's true or false. Because the value of the property is unchanged, it's true in the app component, Angular disables the button. Often interpolation and property binding can achieve the same result. The following binding pairs do the same thing. One note: evaluation of a template expression should have no visible side effects. You shouldn't be assigning anything in the template expression or using increment or decrement operators. If you had an expression that changed the value of something else that you were binding to, the change of value would be a side effect. Now, let's see what are attribute, class, and style bindings. Using these bindings, you can improve accessibility, dynamically style your application, and update classes on the fly.
First, let's talk about attribute binding. Attribute binding in Angular helps you set values for attributes directly. It is recommended that you set an element property with a property binding whenever possible. However, sometimes you don't have an element property to bind. In those situations, you can use attribute binding. Attribute binding syntax resembles property binding, but instead of an element property between brackets, you precede the name of the attribute with prefix attr followed by a dot. Then, you set the attribute value with an expression that resolves to a string. Another common use case for attribute binding is with the callspan attribute in tables. Binding the callspan attribute helps you keep your tables programmatically dynamic. Depending on the amount of data that your application populates a table with, the number of columns that a row span could change. To use attribute binding with the TD attribute callspan, specify the callspan attribute by using this syntax. Set attribute callspan equal to an expression. In this example, we bind the callspan attribute to the expression 1 plus 1. This binding causes the table row to span 2 columns. Sometimes there are differences between the name of property and an attribute. Callspan is an attribute of table row, while callspan with the capital S is a property. When using attribute binding, use callspan with a lowercase s. For more information on how to bind to the callspan property, check out the video about the property binding. Now, let's move to class binding. You can use class binding to add and remove CSS class names from an elements class attribute. To create a single class binding, use the prefix class followed by a dot and the name of the CSS class. Angular adds the class when the bound expression on sale is truthy. And it removes the class when the expression is falsy, with the exception of undefined. To bind the multiple classes, use class set to an expression. The expression can be one of a space-delimited string of class names, an object with class names as the keys and 30 or falsy expressions as the values, an array of class names. With the object format, Angular adds a class only if its associated value is truthy. And finally, let's talk about style binding. You can use style binding to set styles dynamically. To create a single style binding, use the prefix style followed by a dot and the name of the CSS style property. Angular sets the property to the value of the bound expression, which is usually a string. Optionally, you can add a unit extension like m or percentage, which requires a number type. You can write a style property name in either dash case or camel case. To toggle multiple styles, bind to the style attribute, the style expression. The style expression can be one of a string list of styles, or an object with style names as the keys and style values as the values. And note that binding an array to style is not supported. This time I'm talking about event binding. Event binding allows you to listen for and respond to user actions, such as keystroke, mouse movements, clicks, and touches. It's similar to float fishing, as you're waiting for a fish to take your bite, and once it drips off, you respond quickly and strike. To bind an event, you use the Angular event binding syntax. This syntax consists of an event name within parentheses to the left of an equal sign and a template statement to the right. In this example, the event name is click and the template statement is onSave. We can now define the onSave method in our TS class. And once we click our button, that event has been bound and our method is executed.
We can also bind to custom events. To demonstrate that, I'll create an item details component. In this component, I'll create an event emitter with output decorator, which exposes our property to parent components. Then I'll create a delete dummy method, which will just emit our property once we call it. Now, I'll define a button and bind this method to a click event. Next, I'll place our item details component in our app component, and I will bind to the delete request custom event that we just created. I'm calling delete item method, and I'll use the event parameter to catch the string sent with this event. And now I'll define the delete item method in our class and just log what we got. And that's how you bind to a custom event. Now let's see two-way binding in action. Two-way binding is the concept of sharing and giving. What you give is what you can expect from others. Why two-way binding? Two-way binding gives components in your application a way to share data. Use two-way binding to listen for events and update values simultaneously between parent and child components. Angular's two-way binding syntax is a combination of square brackets and parentheses. This syntax combines the brackets of the property binding with the parentheses of event binding. I'll create a sizer component. In our component, I will define a size value property and a size change event. The size property is an input, so data can flow into the sizer component. The size change event is an output, which allows data to flow out of the sizer component to the parent component. Next, there are two methods, dec to decrease the font size and inc to increase the font size. These two methods use resize to change the value of the size property within min-max value constraints. And to emit an event that conveys the new size value. In the sizer component template, I'll create two buttons that each bind the click event to the inc and dec methods. When the user clicks one of the buttons, the sizer component calls the corresponding method. Both methods, inc and dec, call the resize method with a +1 or -1, which in turn raises the size change event with the new size value. And below them, I'll add a label which displays size property and dynamically updates its own font size. In our root app component, I'll include an app sizer component, and I will use two-way binding to bind font size px property to the sizer component. And below that, I'll add a div, which will utilize this property to adjust its text size. In the app component, font size px establishes the initial sizer component size value by setting the value to 16. Clicking the button updates the app component font size px. The revised font size px value updates the style binding, which makes the display text bigger or smaller. The two-way binding syntax is shorthand for a combination of property binding and event binding. The sizer component binding has separate property binding, and event binding is as follows. The event variable contains the data of the sizer component size change event. Angular assigns the event value to app component font size px when the user clicks the buttons. To use two-way binding with form elements, we need ng model, which I will cover in the forms section. Next ones are template variables. Template variables helps you to use data from one part of a template in another part of a template. It's a variable that is created in and identifies a component or element within the template itself. So it's like a phone number of a component, which you can use to call it in case you need something from it. With template variables, you can perform tasks such as respond to user input or finely tune your application's form. Syntax. In the template, you use the hash symbol to declare a template variable. The following template variable, phone, declares a phone variable on an input element. You can refer to a template variable anywhere in the component's template. Here, a button further down the template refers to the phone variable. Now, we can define the callPhone method and log the passed value, which is the actual value of the input. So, what is the template variable scope? You can refer to a template variable anywhere within its surrounding template. Structural directives such as ngIf and ngFor, which we'll cover in the later videos, or ngTemplate, act as a template boundary. You cannot access template variables outside of these boundaries. So, can we access variables in a nested template? An inner template can access template variables that the outer template defines. In the following example, changing the text in the input changes the value in the span because Angular immediately updates changes through the template variable ref1. In this case, there is an implied ng template around the span and the definition of the variable is outside of it. So it's the same thing as writing it explicitly like this. However, accessing a template variable from outside the parent template doesn't work. It's the same as writing the following. And that's all for template variables. Now, let's discuss directives. It's the same as if you are a CEO of the company and you are giving directives to your employees how to behave and what to do in certain situations. What are directives? Directives are classes that add additional behavior to elements in your Angular application. With Angular built-in directives, you can manage forms, lists, styles, and what users see. The different type of Angular directives are as follows. Components directives with a template. This type of directive is the most common directive type. Attribute directives. Directives that change the appearance or behavior of an element, component, or another directive. Structural directives. Directives that change the DOM layout by adding and removing DOM elements. Today, we are talking about built-in attribute directives. Attribute directive listens to and modifies the behavior of other HTML elements, attributes, properties, and components. Many ng modules such as router module and forms module define their own attribute directives. The most common attribute directives are as follows. ng class adds and removes a set of CSS classes. ng style adds and removes a set of HTML styles. ng model adds two-way data binding to an HTML form element. How to add and remove classes with ng class. You can add or remove multiple CSS classes simultaneously with ng class. To add or remove a single class, use class binding rather than ng class. On the element you like to style, add ng class and set it to equal to an expression. In our class, let's define eSpecial as true. Because eSpecial is true, ng class applies the class of special to the div. To use ngClass with a method, add method to the component class. In the following example, setCurrentClasses sets the property currentClasses with an object that adds or removes three classes based on the true or false state of three other component properties. Each key of the object is a CSS class name. If a key is a true, ngClass adds the class. If a key is false, ngClass removes the class. Boolean values are hard-coded just for demonstration. In the template, add the ngClass property binding to current class to set the elements classes. And now we can preview our classes. Now, let's talk about ngStyle. You can use ngStyle to set multiple inline styles simultaneously based on the state of the component. To use ngStyle, add a method to component class. Add empty object currentStyle. In the following example, setCurrentStyles sets the property currentStyles with an object that defines three styles. To set element styles, add an ngStyle property binding to currentStyles. For this use case, Angular applies the styles upon initializations and in case of changes. To do this, the full example calls setCurrentStyles initially with ngOn in it. And the last one in today's video is ngModel. You can use the ngModel directive to display a data property and update that property when the user makes changes. Import Forms module and add it to ngModule's import list. I'll create a label and an input for this example. Add an ngModel binding of an HTML form element and set it equal to the property, here its name. Now, if we define property inside of our component class, you can see how ngModel directive adds two-way data binding to our input. This ngModel syntax can only set a data-bound property. When you write an Angular component, you don't need a value accessor or ngModel if you name the value and event properties according to Angular's two-way binding syntax. And that's all for this section. In this section, we are continuing with Angular directives. Let's build attribute directive. Let's create a file, highlight.directive.ts, which is the convention that you always should follow. Next, import directive decorator from core and implement that decorator with selector property. For me, it's going to be app highlight. Next, we want to export our class. And the last thing we want is to import that in our declarations array in app module. That's our directive boilerplate code, which you can also get with the command ng generate directive highlight. Import element ref from Angular core. Element ref grants direct access to the host DOM element through its native element property. Add element ref in the directives constructor to inject a reference to host DOM element, the element to which you apply app highlight. Add logic to the highlight directive class that sets the background to yellow. To use the highlight directive, add a paragraph element to the HTML template with the directive as an attribute. Angular creates an instance of highlight directive class and injects a reference to the paragraph element into directives constructor, which sets the p element's background style to yellow. Now, let's see how to detect when a user mouses into or out of the element, and to respond by setting or clearing the highlight color. Import host listener from Angular core. Add two event handlers that respond when the mouse enters or leaves, each with the host listener decorator. With the host listener decorator, you can subscribe to events of the DOM element that hosts an attribute directive, the paragraph in this case. The handlers delegate to a helper method highlight that sets the color on the host DOM element, L. The background color appears when the pointer hovers over the paragraph element and disappears as the pointer moves out. Now, let's see how we can make that directive dynamic to be able to use it at different places with different colors. In Highlight Directive TS file, import input from Angular core. Add an app highlight input property. The input decorator adds metadata to the class that makes the directive app highlight property available for binding. In app component TS, add a color property to the app component. To simultaneously apply the directive and the color, use the property binding with the app highlight directive selector, setting to equal to color. The app highlight attribute binding performs two tasks: applies the highlighting directive to the paragraph element, and sets the directive highlight color with a property binding. And that's all for this one. This is the last section about directives, so let's see what are structural directives. Structural directives are responsible for HTML layout. They shape or reshape the DOM structure, typically by adding, removing, and manipulating the host elements to which they are attached. This section introduces the most common built-in structural directives. ngIf conditionally creates or disposes of subviews from the template. ngFor repeat a node for each item in a list. ngSwitch a set of directives that switch among alternative views. You can add or remove an element by applying an ngIf directive to a host element. When ngIf is false, Angular removes an element and its descendants from the DOM. Angular then disposes of their components, which frees up memory and resources. To add or remove an element, bind ngIf to a condition expression such as isActive in this example. When the isActive expression returns a true value, ngIf adds the div to the DOM. When the expression is falsy, ngIf removes the div from the DOM. That's simple, right? Now, let's talk about ngFor. You can use the ngFor directive to present a list of items. Let's create an array of objects with the name property in it. Define a block of HTML that determines how Angular renders a single item. To list your items, assign the shorthand let item of items to ngFor. The string let item of items instructs Angular to do the following. Store each item in the items array in the local item looping variable. Make each item available to the template HTML for each iteration. Translate let item of items into ngTemplate around the host element. Repeat the ngTemplate for each item in the list. By the way, you can get the index of ngFor in a template input variable and use it in the template. In the ngFor, add a semicolon and let I equals to index to the shorthand. The following example gets the index in a variable named I and displays it within the item name. And the last directive which we are going to talk about is switch. Like the JavaScript switch statement, ngSwitch displays one element from among several possible elements based on a switch condition. Angular puts only the selected element into the DOM. ngSwitch is a set of three directives. ngSwitch, an attribute directive that changes the behavior of its companion directives. ngSwitch case, structural directive that adds its element to the DOM when its bound value equals the switch value and removes its bound value when it doesn't equal the switch value.
ng switch default, structural directive that adds its element to the DOM when there is no selected ng switch case. I'll modify the items array to be just a single item. On an element such as a div, add ng switch bound to an expression that returns the switch value, such as a name. Though the name value in this example is a string, the switch value can be of any type. Bind to ng switch case and ng switch default on the elements for the cases. And now, depending on the value of the item name, rendering on the page changes. If we didn't provide a case for the name value, default will be executed.
Next, we are discussing dependency injection.
Dependencies are services or objects that a class needs to perform its function. Dependency injection, or DI, is a design pattern in which a class requests dependencies from external sources rather than creating them. You can look at it as if you are adding an extension to your browser or adding an app to your phone. Once you add it, you provide yourself with the new functionalities and features.
Nice extension.
Let's create a service which we can inject in our components. Create a new file with the name log.service.ts. Import injectable decorator from Angular core. And then for provided in metadata, add root value, which means that we are going to provide the service in the root of the application and that it's visible throughout the application. Export our log service class, and inside of this service, we want to add our log message method, which will just log past messages. For clarity and maintainability, it is recommended that you define components and services in separate files. Now, inject our log service into the app module file in providers array. Injecting service results in making them visible to a component. To inject a dependency in components constructor, supply a constructor argument with dependency type. The following example specifies the log service in the app component constructor. The type of log service is log service. Now we can reference our log service in our component and call our method from it. We should pass our message, and as you can see, it's being executed as expected. We can use this approach to inject third-party libraries and other modules that are available in Angular framework. So let's inject Renderer2 module, which is used for custom rendering and updating the DOM. Import Renderer2 from Angular core and inject it inside the constructor. Also, we will need element ref, which we can use for referencing our DOM elements or the host component in our case. Now, inside the ng-onInit lifecycle, call the setStyle method of the renderer and set the color of host native element to red. This method changes the color of our component's text, and as you can see with the dependency injection, we get access to more features and methods. That's all there is to it.
Next is very important topic, routing.
The Angular router is a core part of Angular platform. It enables developers to build single-page applications with multiple views and allow navigation between these views. We can compare routing of our applications with navigating a plane. Pilot sets the flight coordinates, in our case route path, and the plane lands on the desired location or desired page in our app. Oftentimes, planes carries goods or cargo, and routes carry params info and data. And unfortunately, some planes do get crashed or lost, and for routes sometimes we get 404. To use the Angular router, an application needs to have at least two components so that it can navigate from one to other. To create a component using the CLI,
Enter the following at the command line, where first is the name of your component. ng generate component first. Repeat this step for a second component, but give it a different name. Here the new name is second. This guide works with a CLI-generated Angular application. If you are working manually, make sure that you have base href with slash in the head of your index.html file. This assumes that the app folder is the application root and that uses slash. Create a new module for routing. Name it app-routing.module. Define const routes, which is type of routes. Here we will define our paths and components. Inside ng module imports array, add router module and call forRoute module with routes passed as argument. Then export your router module so it can be imported into the route module. At the end, define the app routing module class. Import the app routing module into app module and add it to the imports array. Now, define your routes in your routes array. Each route in this array is a JavaScript object that contains two properties. The first property, path, defines the URL path for the route. The second property, component, defines the component that Angular should use for the corresponding path. Now that you have defined your routes, you can add them to your application. First, add links to the two components. Assign the anchor tag that you want to add the route to the router link attribute. Set the value of the attribute to the component to show when a user clicks on each link. Next, update your component template to include router outlet. This element informs Angular to update the application view with the component for the selected route. You can add router link active attribute if you want to style active link. One note, the order of routes is important because the router uses a first match wins strategy when matching routes, so more specific routes should be placed above less specific routes. Often, as a user navigates your application, you want to pass information from one component to another. To do so, you use the activated route interface. First, import router, activated route, and param map to your component. Inject an instance of activated route by adding it to your application's constructor. Update the ng-oninit method to access the activated route and track the ID parameter. Now we need to adjust our routes to pass the ID param as well. In path, add semicolon and name of your parameter. And then we can add ID values to our links. That's how you pass and retrieve data from one component to another. A well-functioning application should gracefully handle when user attempts to navigate to a part of your application that doesn't exist. To add this functionality to your application, you set up a wildcard route. The Angular route selects this route anytime the requested URL doesn't match any router paths. To set up a wildcard route, add the following code to your route's definition. For the component property, you can define any component in your application. Common choices include an application-specific page-not-found component, but here I'm just redirecting to the first component. And now, if you navigate to any random path, it will always give us first component. As your application grows more complex, you may want to create routes that are relative to the component other than your route component. These types of nested routes are called child routes. This means you're adding a second router outlet to your app because it is in addition to the router outlet in app component. In this example, there are two additional child components, child A and child B. Here, first component has its own nav and a second router outlet in addition to the one in app component. Also, I'm gonna create two child routes with the router links of child A and child B. And give it a second router link. Now, I'll create two additional components with Angular CLI and name their child A component and child B component. A child route is like any other route, in that it needs both a path and a component. The one difference is that you place child routes in a children array within the parent route. Now, if we navigate to any of child routes, we get the corresponding child component. Use route guards to prevent users from navigating to parts of an application without authorization. The following route guards are available in Angular: can activate child, can deactivate, resolve, and can load. Create a service for your guard. ng-generate guard your guard. In your guard class, implement the guard you want to use. The following example uses can activate to guard the route. Now, depending on your logic, it can return true or false. Usually it checks if the user is logged in or does he have privileges to access the page. In your routing module, use the appropriate property in your route's configuration. Here, can activate tells the router to mediate navigation to this particular route. Now, if we set the guard to false, we can't access the route. Otherwise, we can. And that's all for routing for this section. After this one, we are covering one even more important concept, and that is Angular Forms. Let's start off with template-driven forms. I know it sounds impossible, but there were times when there was no internet or even computer. So in those times, we had to fill out good old paper forms when we wanted to visit a doctor or to apply for various personal documents. So web forms are nothing different except they're digital. Angular supports two design approaches for interactive forms. Template-driven forms are suitable for small or simple forms, while reactive forms are more scalable and suitable for complex forms. This tutorial shows you how to build a form from scratch. First, import Forms module in your app root module. Let's first build our path class, which defines a data model reflected in our form. I will have three properties: ID, name, and species. Now, let's import our class in the app component. Define species in species array. Now, create a model from the pet class and pass the values for our pet. Here we are using dummy data, but in your real app you would use a service to get the data from the API and to save it. Also, let's add submitted property, which will change depending on the state of the form and on submit method. Next, in our HTML file, we will create a form that reflects our data model. Create a form and inside it two divs for two fields. First will be name input. And I'm adding a label and required attribute to our input. And the second one will be a select, which will loop through an array of species to show all the values from the array. Same as for input, I'm adding a label for our select, and also I will add required attribute. Then I will use ng4 to loop through all the values and display them. If you run the application right now, you see the list of species in the selection control. The input elements are not yet bound to data values or events, so they are still blank and have no behavior. The next step is to bind the input controls to the corresponding pet properties with two-way data binding so that they respond to the user input by updating the data model and also respond to programmatic changes in the data by updating the display. The ng model directive declared in the Forms module lets you bind controls in your template-driven form to properties in your data model. Add the ng model directive using two-way data binding syntax. For the name, use model.name. And for species, use model.species_value. When you use ng model on an element, you must define a name attribute for that element. Angular uses the assigned name to register the element with the ng-form directive attached to the parent form element. So, in order to register our form, add a template reference variable with a value of ng-form. The pet form template variable is now a reference to the ng-form directive instance that governs the form as a whole. In order to test our application, place the model object in our template with a JSON pipe. Now, if you update your form fields, you will see that model is being updated. Now the user should be able to submit this form after filling it. Create a submit button on the bottom. The submit button at the bottom of the form does nothing on its own, but it does trigger a form submit event because of its type, submit. To respond to this event, take the following steps. Bind the form's ng-submit event property to the pet form component on submit method. Use the template reference variable, pet form, to access the form that contains the submit button and create an event binding. You will bind the form property that indicates its overall validity to the submit button's disabled property. Run the application now. Notice that the button is enabled, although it doesn't do anything useful yet. Delete the name value. This violates the required rule, so it disables the submit button. To show a response to form submission, you can hide the data entry area and display something else in its place. Wrap the entire form in a div and bind its hidden property to the app component submitted property. The main form is visible from the start because the submitted property is false until you submit the form, as this fragment from the app component shows. To show something else while the form is in submitted state, add the following HTML below the new div wrapper. Add the properties that you updated and the edit button if the user wants to update the fields again. And now let's preview how it works. That's all about template-driven forms. Now in the next section, we're gonna see how we can take more control of our forms and how to create reactive forms. Reactive forms provide a model-driven approach to handling form inputs whose values change over time. Each change to the form state returns a new state, which maintains the integrity of the model between changes. Let's add basic form control. To use reactive form controls, import Reactive Forms module from Angular Forms package and add it to your ng modules import array. To register a single form control, import a form control class and create a new instance of form control to save as a class property. Use the constructor of form control to set its initial value, which in this case is an empty string. By creating these controls in your component class, you get immediate access to listen for, update, and validate the state of the form input. After you create a control in the component class, you must associate it with a form control element in the template. Update the template with the form control using the form control binding provided by form control directive, which is also included in the Reactive Forms module. Using the template binding syntax, the form control is now registered to the name input element in the template. You can display the value in the following ways. Through the value changes observable, where you can listen for changes in the forms value in the template using async pipe, or in the component class using the subscribe method, or with the value property, which gives you a snapshot of the current value. The following example shows you how to display the current value using interpolation in the template. The displayed value changes as you update the form control element. Reactive forms have methods to change the control's value programmatically, which gives you the flexibility to update the value without user interaction. The following example adds a method to the component class to update the value of the control to Nancy using the setValue method. Update the template with a button to simulate a name update. When you click the Update Name button, the value entered in the form control element is reflected as its current value. The form model is the source of truth for the control, so when you click the button, the value of the input is changed within the component class, overriding its current value. Forms typically contain several related controls. Reactive forms provide two ways of grouping multiple related controls into a single input form. First way, a form group defines a form with a fixed set of controls that you can manage together. And second way, a form array defines a dynamic form where you can add and remove controls at runtime. Import the form group and form control classes from the Angular Forms package. Create a property in the component class named Profile Form and set the property to a new form group instance. To initialize the form group, provide the constructor with an object of named keys mapped to their control. For the profile form, add two form control instances with the names first name and last name. The individual form controls are now collected within a group. After you define the model, you must update the template to reflect the model in the view. I'm adding two inputs and two labels that match our model. The form control name input provided by the form control name directive binds each individual input to the form control defined in the form group. The form group directive listens for the submit event emitted by the form element and emits an ng submit event that you can bind to a callback function. add an ng-submit event listener to the form tag with the onSubmit callback method. The onSubmit method captures the current value of profile form. Here, we will just log the form value. The submit event is emitted by the form tag using the native DOM event. You trigger the event by clicking a button with submit type. This allows the user to press the enter key to submit the completed form. Add a button to the bottom of the form to trigger the form submission. And that's all for Reactive Forms. In the next section, we're gonna see how we can improve our forms. So, in this section, we are covering form validation. This tutorial will show you how to validate user input from the UI and display useful validation messages in both reactive and template-driven forms. Anything that you want to store to your database needs to have multiple levels of validation. And I see validation the same as if you're at an audition or job interview. Something, or rather someone, is presented to you, and you decide will he pass or not. To add validation to a template-driven form, you add the same validation attributes as you would with native HTML form validation. Angular uses directives to match these attributes with validator functions in the framework. Every time the value of a form control changes, Angular runs validation and generates either a list of validation errors that results in an invalid status, or null, which results in a valid status. I'll create a name string field inside of our component class. Then, in our HTML file, I'll add an input text field with required attribute and min length of 4. I'm binding name input property to ngModel, and I'm exporting ngModel to a local variable called name. ngModel mirrors many of the properties of its underlying form control instance, so you can use this in template to check for control states such as valid and dirty. The ngIf of the div element reveals a set of nested messages divs, but only if the name is invalid and the control is either dirty or touched. Each nested div can present a custom message for one of the possible validation errors. These are messages for required and min length. Now, if we type something and leave the field empty, we will get the validation error message. And the same goes if we enter value less than 4 characters long. In a reactive form, the source of truth is the component class. Instead of adding validators through attributes in the template, you add validator function directly to the form control model in the component class. The same built-in validators that are available as attributes in template-driven forms, such as required and min length, are all available to use as functions from the validator class. To update the validation form to be a reactive form, use some of the same built-in validators. In this example, the name control sets up 2 built-in validators, validators required and validators min length. These validators are synchronous, so they are passed as the second argument. Notice that you can support multiple validators by passing the functions in as an array. This example also adds a getter method. In a reactive form, you can always access any form control through the get method on its parent group, but sometimes it's useful to define getters as shorthand for the template. In our template, add form group to our form. And now, only thing that we need to change in our template to make it reactive is to remove ng model and to bind our name control to form control name. This form differs from the template-driven version in that it no longer exports any directives. Instead, it uses the name getter defined in the component class. Notice that the required attribute is still present in the template. Although it's not necessary for validation, it should be retained for accessibility purpose. We finally came to the end of this long tutorial, and we're gonna cover communication using HTTP client. Imagine that you're running a TV station or a newspaper, and what if you lose communication with your reporters? You would end up with a blank newspaper or no news to broadcast.
Oh my god.
It's the same thing with web apps. Without backend communication, our apps would be dead, without informations or instructions from the backend. Most front-end applications need to communicate with a server over HTTP protocol to download or upload data and access other backend services. Before you can use HTTP client, you need to import Angular HTTP client module. Most apps do so in the root app module. Let's create data service. Most common use case is to inject HTTP client into service and use it throughout the application. You can then inject HTTP client service as a dependency of an application class, as shown in this example. Now let's see how we can fetch data from a server. To do that, we're gonna use HTTP client get method. First, inject HTTP client into our service. Then create getData method, and inside of this method, we're gonna fetch our data. The get method takes two arguments, the endpoint URL from which to fetch and an options object that you use to configure the request, to add things like parameters to your requests. For this tutorial, I found a free Cocktail API service. The link will be in the description box below. Enter the URL and no additional parameters are required in this case. Now, in our app component, we inject the data service in the constructor. And inside of ng-oninit method, let's call our getData method. Because the service method returns an observable, the component subscribes to the method's return value. I'm just gonna console log it. And that's how you get data from the server. In an ideal world, everything works as a magic, but we don't live in an ideal world.
Unfortunately.
And we lose connection with API sometimes. So we need to handle errors when they come up. If the request fails on the server, HTTP client returns an error object instead of a successful response. Let's add a pipe on our get method and use catch error to catch it. I'm gonna log the error for development purpose and return throw error with some message. This should be used in your application to show the user that his request has failed. Without notification, they wouldn't know what's happening. And don't forget to import missing packages. Now we can change the URL to break the request and to see the error. We usually don't want to see this view in our applications, but we need to be ready for that when it happens. HTTP client, besides get, also has a post method for submitting data to server. For example, if you are submitting a form. We have delete request for deleting data from database, obviously. A put request which replaces a resource with updated data. Now, most of the APIs require an authentication key with their requests. So let's see how we can add that. I found this Lord of Rings database which requires an auth key. Let's create HTTP options object with a headers property. This property will be a new HTTP headers object and we will pass two properties. Content type as application JSON, which means that we are using JSON as content. and authorization, where we enter our API key. Barrier is type of authorization and followed by a key. In order to get your personal key, you need to register. Link is in the description box below. Now update the API endpoint. And if you try to call without passing the HTTP options, you can see that we get an error. But if we add authorization, the request is successful. And now let's proceed to the last section. Welcome to the last section in this video course. Let's talk about HTTP interceptors. This concept reminds me of a telephone exchange. Every single phone call is going through the central office, and operators are in charge of establishing phone calls between subscribers. With interception, you declare interceptors that inspect and transform HTTP requests from your application to a server. Interceptors can perform a variety of implicit tasks, from authentication to logging, for every HTTP request. Without interception, developers would have to implement these tasks explicitly for each HTTP client method call. Let's create one. Add file with a name testinterceptor.ts. Now add injectable metadata. To implement an interceptor, declare a class that implements the intercept method of the HTTP interceptor interface. Now, let's add an intercept method. Apps often use an interceptor to set default headers on outgoing requests. Now, I'll add authentication for the movie API from the previous video. For more information on how to get token and other information regarding this API, please check the previous video. Links are in the description below. If we inspect the request in our app right now, you can see that we don't have authorization sent with our request, and our request fails. Let's add it. Here, the only thing we are doing is cloning the request and setting headers to the same request. And finally, we return that cloned request. To inject our interceptor, I add it to providers array in the root module. And now, if we load the page, we can see that in requests, we are getting authentication sent with every request. That's all for the basic Angular introduction. In the next video series, I'm gonna cover more advanced Angular topics like testing, animations, translations, service workers, and similar. If you want to support my channel, please like, share, and subscribe. And I see you guys in the next one. Take care.